Today on Math with Rob, we're going to discuss the two-sided derivative. We'll define the two-sided derivative in terms of the difference quotient as the limit as h approaches 0 of f of x plus h minus f of x minus h over 2h. We'll derive the formula for the derivative from the slope formula, and we'll compute the two-sided derivative of f of x equals x squared. Finally, we'll assign an exercise and cover the solution. It's true that if f of x is differentiable at x, then the right-hand derivative, the left-hand derivative, the two-sided derivative, and all the other possible derivatives are equivalent and called the derivative. The derivative definition comes from the slope formula. The derivative, remember, is the slope of the tangent line at a particular point. And so to derive this slope of the tangent line at a particular point, we parameterize a family of secant lines centered at a particular point by a parameter h, and let this h go to 0. The derivative is the slope of the tangent line to the curve at a particular point, and the slope is given by y2 minus y1 over x2 minus x1. So we draw this picture where we start at a point x, go over by an amount h to x plus h, go up to f of x plus h, go back to x minus h, and then go up to f of x minus h, and we draw the secant line between this point and this point. So algebraically, we let y2 equal f of x plus h, y1 equal f of x minus h, x2 equal x plus h, and x1 equal x minus h. So we substitute these values into the slope formula and we get the slope of the secant line. Notice that x plus h minus x minus h is just 2h. As the horizontal distance h goes to 0, the slope of the secant line becomes the slope of the tangent line, or the derivative. So f prime of x equals df dx equals the limit as h approaches 0 of f of x plus h minus f of x minus h over 2h. Let's do an example. In this example, f of x plus h equals x plus h squared, and f of x minus h equals x minus h squared. We plug these values into our definition of the derivative. F prime of x equals the limit as h approaches 0 of x plus h squared minus x minus h squared over 2h. We expand the x plus h into x squared plus 2xh plus h squared, and we expand the x minus h squared into x squared minus 2xh plus h squared. Next we do x squared minus x squared, 2xh minus 2xh, and h squared minus h squared. We're left with 2xh minus 2xh, or 4xh, and on the bottom we have a 2h. We notice that this has a removable discontinuity as h approaches 0, and so we simplify the difference quotient and we get 2x. The limit of 2x as h approaches 0 is just going to be 2x. So next we do as an exercise x squared plus 2x plus 1. Please compute the two-sided derivative of this function. Pause the video here. Okay, you're back. First, we plug in x plus h into the function and get x plus h squared plus 2x plus h plus 1. Second, we plug in x minus h into the function, we get x minus h squared plus 2x minus h plus 1. And then we break this difference quotient up into three difference quotients. One for this quadratic part, one for the linear part, and one for the constant part. X plus h squared minus x minus h squared simplifies as 4xh as we saw before. 2x plus h minus 2x minus h simplifies as 4h, because the 2x and the 2x cancel, and the 2h minus 2h becomes positive 4h. 1 minus 1 is of course 0, and now we simplify these quotients by removing the discontinuity. 4xh over 2h is just 2x, 4h over 2h is just 2, and 0 is just 2, 0. Next, we take the limit as h approaches 0, and we get 2x plus 2. Great.